Fine. So let's start the class without wasting any more time. See, first of all, when you talk about networking, the first two terms that comes to our mind is called network and protocol. Now we should understand the concept or the basic logic of what do you mean by network and what do you mean by protocol. So first of all, what is network? If somebody asks you this question 15 years before, we can simply tell network can be defined as connecting two or more computers to exchange a valuable data. This we have been studying since our school days, 6th standard, 7th standard and all. People say this. But as of today, not only computer is having network, right? Network is where all devices. So as of today, I can modify this and I can tell network can be defined as connecting two or more devices to exchange a valuable data. So in this given example, I have taken 4 PCs and the red dot is data being exchanged between them. I can call this as a network. So network became so common word that anybody can use the term called network. For example, my grandmom, while talking to phone, she can tell I'm not getting proper network. I'm not getting proper signal. She don't know what is networking, but still she used the word I'm not getting network. What does that she mean to say is that the communication between the cell phone and cell phone tower is not proper. That's what she's trying to tell you. So the network, even the people who are selling vegetables outside the street, even they can use the word network while talking on the call and all. This network, tower, Wi-Fi. These days it's become so common. So it's no more technical term, I should say. The next word. So finally, network can be defined as connecting two or more devices and exchanging a data. Devices can be a computer, devices can be two mobile phone, switch, fridge, washing machine, TV, even smart bulbs you are having, all are network. So whenever two devices communicates and exchanges some data, that is network. Simple. The next term that comes to our mind is called protocols. Now, what do you mean by protocol? See, protocols are the rules governing the communication. Now, what do you mean by this? Say, imagine you go to a college. They will say protocol is you have to wear the ID card, which I forgot. So, protocol is you have to wear the ID card, and while going to college, you should not wear jean. In my generation, it was like that. So we have to wear formals and all. We have to do tuck in. When you go to office, you have to be in a presentable way. So protocol is that also. And also when you communicate with someone, depending on with whom you are talking to, like your father, your mother, your friend, sister, there will be separate rules applicable, except friends. With friends, we talk everything. So protocol means what? Simply the rules governing the communication. Okay. Like if Sam knows only Japanese and Kathy talks only Hindi, if they want to communicate, is it possible? No. Why not possible? Because the protocol says they should know same language or else they cannot talk. In similar way, your computer also has a protocol. One of the major protocol is that IP. IP expands to what? Internet protocol. So this internet protocol, it can be further divided into two pieces. I can tell it as inter network protocol. It's like inter network protocol. So we can easily think when I say inter network protocol, whenever we want to communicate between the network, inter network, we use IP. So does that mean within network, I don't want IP address? Is that true? If you think yes, within the network, for example, I have two mobile phones with me, and if I want to exchange file between them, do I want internet? No, I can exchange using Bluetooth. I have NFC, I have RF. So what it needs? Only the MAC address. So we can come to conclusion that IP address is used between the network and MAC address is used within the network. So if you want to have intra-network communication like Bluetooth, MAC address is enough. No need to have IP address. But if you want to communicate between two networks, I have an office in India, another office in China, I want to communicate, we need to have an IP address. Now the question comes, how does an IP address looks like? It looks like this, 10.001, 10.002. That's how an IP address looks like. So IP address consists of 4 numbers like this, separated by 3 dots. And these numbers will be in the range of 0 to 255. So in less than 2 minutes, you can easily tell if someone gives you an IP address, you can easily tell whether it's a right IP or wrong IP. See, for a number to be an IP address, condition is very simple. It should have 4 numbers and each number should be in the range of 0 to 255. Okay. So you guys can respond in chat yes or no, or yes or simply N with the answer whether the given IP address is right or wrong. Let's start on this one. 10.0, 10.10.10.10. Is it a right IP or wrong IP? Ping yes or N in chat. For classroom, if it is right, you can raise hand. Correct. Right. So 10.11.12.13. Is it a right or wrong? Right. 123.156. Something. It has 4 numbers, all in the same range. Correct. No need to even have a second thought. 178.256.190.185. Is it correct? No. This is a wrong IP address. It because the second number is exceeding 255. So globally, now you guys can, anyone can give you any IP address and you can easily tell is it a right IP or wrong IP address. So that's very simple process. Now let's see the 3 different types of communications we are having. See, networking, there are 3 major types of communications. One is your unicast communication. Second is called multicast. Third is called broadcast. Now, what do you mean by unicast communication? Unicast communication means when one device communicates to only one device. When one person talks to one person, that's called unicast. Multicast means one to a group of people. That's called multicast. It's not with everyone. Not all are talking. Just one with a group of people, not everyone. Broadcast means what? One to all. When one person talks to everyone. For example, imagine in this meeting we have 50 people and I talk to only one person, maybe a person called Arjun. It's called unicast communication. If I talk to 10 people out of 50, that's called multicast. Broadcast means now I'm teaching everyone. So this is a broadcast communication. Now with this small understanding, let me ask you a question again. You guys can ping in chat the answer. Either U for unicast, M for multicast, and B for broadcast. In this given example, I have PC1, 2, 3, and 4. If PC1 talks to only PC2, is it unicast, multicast, or broadcast? Please ping in chat U, M, or B. Great. Second, let's see if PC1 talks to 2 as well as 3, then is it what? Is it multicast or broadcast? It is a multicast, a group of devices. If it is talking to 2, 3 as well as 4, I'm talking to everyone. So when PC1 talks to everyone, that's called what? It's called broadcast, simple. Regarding any cast, we'll see it later once we have some basic understanding and all. Now, there are multiple types of networking designs available in the market, starting with LAN, then we have WAN, SAN, CAN, MAN, VPN, and PAN. Let's see just a one-liner of this thing. LAN expands to local area network, meaning inside one building, inside one room, if I'm connecting 2 or more PCs together, that's called as what? LAN. WAN means I have an office in Chennai, second office in Bangalore, which I have already, which means I need to talk to internet. So this internet is termed as WAN. Simply you can tell, if somebody asks you what is WAN, tell internet is WAN. Then we got SAN. Imagine that you have a very big hard disk. It's a very big hard disk of like maybe 100 TB. And you're connecting that to your laptop and you're exchanging files between them. It's called storage area network. See, I'm just giving you a layman point of view, basic understanding only. Technically, you will learn later in the course. Now, what do you mean by campus area network? Campus area network means, imagine if you're living in a very big apartment, it has 3-4 buildings. Between 3-4 buildings, when they want to communicate, they will be using campus area network only. They'll be termed as campus area network. Next is your VPN. Now, what is MAN? What if I want to connect my Chennai office with Bangalore office using an underground cable? What if I don't want to spend a lot of money in the internet? I just lay a fiber cable which can travel like 200 kilometers. I can connect two offices. That can be termed as metropolitan area network. VPN means, today everyone knows that, virtual private network, for having your device and other device can talk through internet, and that communication will be secure. It will be tunneled communication, secure communication. Nobody can see. Next, PAN. PAN means, in one word I can explain this, Bluetooth, nothing else. So Bluetooth can be termed as personal area network, PAN. PAN expands to personal area network. So once again, in this slide, as of now, just understand the full form. No need to even remember what is inside what, because during the course of CCNA, you will learn all the topics one by one. So by the time you will have more understanding on each concepts here. So as of today, we will break down LAN and WAN. Now, what is LAN? LAN expands to local area network. When we are connecting like 2 or more PCs together inside a single room, I can call it as local area network called LAN. Now the question is, how can I connect them? If I have like 2 PC, how can I connect 2 PCs? I can have to either use Ethernet cable. If I'm using Ethernet cable, that's called as Ethernet LAN. Simple. If I'm using an Ethernet cable, that is termed as Ethernet LAN. Or else I can also use fiber cable. If I'm using fiber cable, that's termed as fiber LAN. Or third last method, Wi-Fi. What if I communicate using wireless network or Wi-Fi? Wi-Fi means wireless LAN. See, when you're using Ethernet cable, the Ethernet cable looks like this. The long cable. So Ethernet cable looks like this. So if you remove this entire thing, it's basically a copper cable. Inside you have copper wires or copper strands. Now these copper wires are equivalent to this wire, which I'm going to hold now in hand. This wire, inside this, what you have? We have copper wire. We also have copper wire. Even that is also copper wire. So basically, Ethernet cables are made up of copper wire. So data are sent and received with the help of what signals? Electrical signals. So data inside the Ethernet cable, they are flowing here and there with the help of vibration. Same method how electrical current passes. In that, we are carrying the data. Second, we have fiber cable, which we already have. Everyone's home is a Wi-Fi now. If you see the yellow cable, slight small one, the fiber cable, it sends and receives data with the help of light signals. It uses light signals. Here you can see an example of a fiber cable. There you see. See the fiber cable, how it looks like. So inside that, we'll have a small fiber port. So in that, we send and receive fiber light signals. With the help of light signals, we are sending and receiving the data. Third, we got wireless. Now in wireless, we use radio frequencies. So, you know, FM radio, AM radio. The term radio came because of the signals in Wi-Fi is termed as radio frequencies. So here the medium is air. It is termed as radio frequency. So this is all about your Ethernet LAN. LAN we can build using three methods: Ethernet cable, fiber cable, and Wi-Fi. Then we got WAN. WAN expands to wide area network. As of today, if anybody asks you, what do you mean by WAN? Just tell them it is internet, nothing else. Internet is termed as WAN as of today, nothing else. Okay. So why do we need internet? Internet is needed only when you have two devices which are very far and they want to talk or communicate. Internet is not required when two devices are closer. When they are nearby, there are like other possible cases. I can simply put a cable and connect and communicate. I can use a USB cable or Ethernet cable or even fiber cable. But internet is required only when you have two devices which are like very far away, like YouTube server and you. So as of today, if somebody asks you what is WAN, just tell them internet is equal to WAN. Here is how the Ethernet cable looks like. There you got the fiber cables with light and just normal yellow wire cable. Now we'll talk about the three major devices in your networking. Let's see it now. I got my devices now. I'll show you. So this device, which you are seeing in my hand now, is your hub device. Okay, it will be in compact size, lightweight. It doesn't have a brain or CPU in it. So without CPU, whatever signals we are sending here, it will pass signal out of all these ports. It is not going to process anything. We cannot configure hub. Nothing we can do. It's a hub device. So next device is your switch. Now comparatively, you can see switches are bigger in size. It has like more number of ports similar to hub, but this has CPU in it. It can think, process. You can control the traffic it is going inside. You can decide the traffic should come here and go out. It's possible. But in hub, nothing. If you send signal, it will take it out of all the ports. That's how your switch looks like. The last one is your router. This is a compact size 184 model number router. If you see the front panel, we don't have any big ports and all, but the back side, you have the ports. These are the two usable ports. This yellow color mentioned is there now. These are the usable ports. Here is the flash card. Is the extra thing we can put on off switch and power socket. That's one model of your router. This for dummy we have used. Second model routers can be big in size also, like high-end routers, which is this one. It's too heavy and big in size, as we can see. Even this will have two ports only. Because routers are always used where one end will be connecting to the LAN, other end will go to the internet. So that's how these three devices looks like. Okay. So these are the three devices majorly used. Apart from that, we have firewalls also. Firewall all looks like same only. The size of that device looks same only. Just that the port and the front panel will change. So let's see the basic difference first between your hub, switch, and router. Now we have seen these three devices. Let's see how hub works or difference between them. See, hub is a half always broadcasting device. When I say always broadcasting device, meaning if you have one PC connected here, second PC connected here, and third PC connected here, if this PC is sending a traffic or data, by default, this PC and this PC will receive it. Always broadcast. It's like this hub. If power is coming in, power will go out of all the port, right? You cannot control. You cannot tell, hey, I want power only in this port. Not possible. Unlike your switches, switches can do both broadcast as well as unicast. When I say this, we have three PC connected again, like this. If PC1 is sending a traffic, we can tell it has to go to only PC2. Only 1 to 2 communications are possible, as well as 1 to all is possible. Think like, imagine the switch. If power is coming in, I can tell only on this port, I want power. Switching on this port. Can I get power on all the ports also? Yes. If I switch on all the ports, all port will get power. Same way it works. Switch is a both broadcast as well as unicast device. Now routers, they are always unicast, meaning if a broadcast packet comes in, routers don't even allow it. Through routers, a broadcast cannot go. Why? Let's imagine. See, broadcast means what? One to all, correct? If you're sending a broadcast to your home router, if that home router allows a broadcast to the internet, in internet, we are having thousands of routers. This broadcast will go, those thousands of routers, again, those thousands of routers will again send the broadcast to further devices. That's why it's very dangerous. Your entire internet will collapse. That's why the routers do not forward the broadcast packet at all. The next major difference is your duplex settings. Hub is a half duplex device, meaning if I'm connecting two PCs together like this, through hub, either he can talk or I can talk. Only one-way communication at a given point of time through the hub. If you are connecting two or more devices, only one person can talk, others can listen, or other person can talk, I can listen. Both of them cannot communicate. Talking about switches, they are full duplex. Meaning, if you have PC here, if he is talking, he can also talk. Meaning, both of them can send and receive traffic at the same time. How about routers? Even routers are full duplex only. Meaning, both the devices can send and receive data at the same time. So half duplex means one-way communication. Full duplex means two-way communication. Simple. The last difference we will understand only understanding the IP address. So we can skip that as of now. So after this, we will learn about small office and home office LAN. Like how do we connect? If we have 4 PC and I want to connect to the internet, how do I how do I put the diagram? How can I connect them? So it goes from PC to switch, then to router. As I informed you, router has only 2 ports. One port goes to LAN. Second port goes to WAN or the internet. Followed by, you will learn about in detail about Ethernet cables. What are different types of cables we are having depending on the speed. We will also talk about fiber cables and types of fiber cables and how to connect them, the color codings and all. Followed by MAC addresses and all. So as I informed you guys, this is going to be a step-by-step approach towards your entire networking journey. So we'll be starting from scratch. So now if you guys have any questions, you can ask me in chat now. Thank you.